In this demo, we will see how to perform a cross-cloud, cross-platform migration of containerized application using RackWare SWIFT. For this demo, we will be migrating WordPress application from GKE cluster to the IBM OpenShift cluster. Let's first look at the source and the destination environments and the application that we will be migrating. This is the source GKE cluster. This cluster is a regional cluster and this cluster is deployed in the US Central 1 region. The KTS version of this cluster is 1.22. Let's access the Kubernetes dashboard for this cluster. We have a namespace named WordPress where the WordPress application is deployed. We can see the workloads from this namespace here. We have a deployment named WordPress, which is the front end of the application, and a stateful set WordPress MariaDB, which is the backend. If we look at the persistent volume claims, we have two PVCs, one for the backend and one for the front end. And the storage class is standard, which is the standard GCP persistent storage. During replication, Swift will list the available storage classes for target volumes and convert the volumes to the selected storage. In this demo, we will be converting these volumes to IBM block storage. Now let's access the application through the load balancer service. So this is the application that we will be migrating, and this is the sample post created for the demo. Now let's look at the destination environment. The destination environment is IBM OCP cluster. This cluster is deployed in the Dallas region and the OpenShift version is 4.9. Now let's access the OpenShift web console. We have pre-created an empty project named WordPress where the WordPress application will be migrated. In this project, we have created a secret named RackWare Try Secret. The RackWare Try Secret has the credentials to access the try image, which is present in the private registry. Try basically stands for transient RackWare agent image. This image is packaged along with the Swift product. During migration, Swift will run try instance as a combination of pod and service under the source and the destination namespace for staging purpose. Along with this secret, we have also created a role binding to grant access of the NUID SSC to the service account used by the application. In upcoming days, you won't need to do this as Swift will give you option during replication to map users, groups and service account to SSC and set the RBAC rules at target. Now let's access the Swift dashboard. You can access the Swift dashboard at this URL, that is IP address of the machine where Swift is installed /swift/dashboard endpoint. During Swift installation, you will be asked to set the initial password for the admin user. So we will be using those credentials to log in. If you need more information about the Swift operations, you can download the operations guide from here and refer to it. For now, let's log in as the admin user. As we don't have any cluster discovered yet, we will be directed to the cluster administration page. So before replication operation, we need to discover both the source and the target clusters. So let's add them one by one. Let's add the source GKE cluster first. I have entered the friendly name for the cluster as the GKE cluster. Selected Google GCP as the cloud type. Here we need to enter the name of the cluster as it is present in GCP cloud. As our cluster is regional, so selected regional cluster and selected the US Central 1 as the region. Added the private key file for the GCP account. Entered the tripod image name and the tripod image secret. So let's add this cluster. So our source cluster is discovered now. Let's discover the destination OpenShift cluster. Here I have entered the friendly name of the target cluster as IBM OCP cluster. Selected the cloud type as IBM OpenShift Container Platform and entered the required cloud details. So let's add this target cluster. So we got our destination cluster discovered too. If we expand this, we can see the summary of the cluster here. Under namespace tab, we can list all the namespaces from the cluster. So if we expand this WordPress namespace, we can even look at the different resources from the namespace. For example, like we have selected pod as an object, so we are looking at the resources from of this type here. If we select persistent volume claim, we can see the PVCs from this namespace.
As we have discovered both the source and the destination clusters, let's perform the sync operation. For that, let's head to all replication under the sync administration tab. Click on new application replication. For the migration process, we will be selecting the sync type as pass-through. In pass-through, the sync runs between the source and the destination cluster directly. There is no any local backup taken under Swift. Let's select the source platform type as Kubernetes. Select the source cluster name, which is GKE cluster. Select the source namespace, which will be WordPress. For applications, you can either select all or selective. If you want to migrate all applications from namespace to the target, you can select all. Or if your namespace consists of multiple applications and you want to migrate a few of them, then you can select selective. You can specify the object type here. Let's add service, and we can add the service. Swift will identify all the related objects and migrate those for you. In our case, we will be migrating a single application, so let's select all. Let's select the platform type for target, which will be OpenShift. Select the target cluster name, which will be IBM OCP cluster. Select the target project, which will be WordPress. This is the list of the storage classes available for the target volumes. Let's select the default one, which is the IBM block storage. Select the zone for the target volumes. The next set of options are for the tripod. Let's keep the try service type as load balancer for source as well as the target. We need to specify the ports for the tripod. We can select auto select ports if we have this range whitelisted in cloud firewalls. Else we can provide the specific ports. Let's provide them. So it will open these ports for us. This is the name of the try image, and this is the name of the image pull secret, which is present in the namespace. Let's add a job name. In advanced options, you can add the customizations, such as we can apply pre and post YAMLs at source cluster, pre and post YAMLs at target cluster. We can even add pre and post scripts to run. In try CPU memory config, we can configure the CPU and the memory request and limit for the tripod at source as well as for the tripod at target. If you want the application at target to use the image from image registry other than the source, you can provide the image registry mapping here. And as target application will use the images from different registries as that of the source, the image pull secret will also be different, and you can specify the pull secret mapping here. In Kubernetes service config, we have service type mapping. Here you can select a service and change the type of the service. In service node port mapping, we can change the node port of the service. You can either provide a particular port or randomize. In volumes sync config, you can include specific list of volumes or exclude specific list of volumes. For now, let's stick to the general options and add the replication job. Now the replication job is running. We can see the live status of the sync operation here. Currently, it is rediscovering the source and the target cluster to get the latest state of the cluster. Now it is taking the snapshots of the volume. As the sync operation is going on, let's try to access the source application. So we can access the source application, and we can even access the sample post created. So there is no any impact of the sync operation going on the source application. Let's wait for the sync operation to complete. Now the replication job is completed. Here we can see the object sync statistics, which objects were migrated. Here we can see the data sync statistics, how much of the volume was transferred. In volume sync summary, you can see the persistent volumes that were transferred. You can also see the checkpoints here. As the replication job is completed, let's look at the destination environment and the resources. In the destination project, we have two pods, one for the front end and one for the back end up and running. We even have the two PVCs as that of the source. Now let's try to access the application through the load balancer service. We can successfully access the application at the target. We can even look at the sample post. Thus, we successfully migrated our application from GKE cluster to the IBM OpenShift cluster.